Hello guys, welcome back to Maths on African Motives, still on our engineering science N3. In this platform, we shall be focusing on motion, power, and energy, which is the question paper from November 2022 exams. From November 2022 exams. So we shall quickly rush through these questions so that we can see what we're supposed to do. So on question number 1, we're given various options are given. As you can see, as possible answers that you're going to be using in each of the questions. Choose the answer and write only a letter, that is the letter from A to D that you're given next to the question number 1.1 to 1.5 in the answer book. Okay, so these are the questions that we have. The first part that we have, that is question 1.1. We are given them that which of the following always act vertically downward to the surface on which a body is placed. It always acts vertically. Take note, guys, it's acting vertically downward. That means we are referring to something always it's going down. Okay, did I indicate the marker there? Okay, I have. So we are referring something that is actually going down. Okay, so let me just try to reduce the marker there so that you can properly see what I'm trying to indicate here. All right, so that's it here. We are referring something that is going down like that. So what is it that is going to affect? That is the gravitational force. Okay, so our answer there is D. If we are referring to the normal force, remember the normal force is the one that is going up. Okay, then the frictional force is the one that is the force due to that is the resistance. Then the tension force, that is, there's an opposition that is happening. So it's not about going down or up. So the proper answer there was a D. On 1.2, the tendency of an object to remain at rest or continue in its uniform motion in a straight line. Okay, what is that tendency? So that is the inertia. So guys, please know the form, please know the definitions of each so that it can help you to attempt these typical questions. All right. On 1.3, we are given that there is an object which is moving, an object moves in a straight line. Okay, so take note, it moves in a straight line, okay, with a uniform acceleration according to the law. So take note, the law that is being used there is S is equivalent to 10t minus 2t squared. So that is what we are given in this case as S representing the displacement in meters, and T is the time in seconds. So take note, your T is the time in seconds. So S we are given, this S is the displacement. Okay, so let's just write here S, that is our displacement. All right, so we have got displacement here, and we are given our T representing the time in seconds. All right, so this is the time in seconds. The displacement is given in meters. Okay, so the question is to calculate on 1.31 the displacement in 2 seconds. Take note, we are given the time and we are given the formula for displacement, which is S is equivalent to 10t, whatever, T representing time. So which means if you are given displacement in 2 seconds, you are simply substituting in place of T, we are going to substitute 2. So our displacement given by S is equivalent to 10 multiplied by 2 minus 2 into 2 squared. Okay, so that's you guys and your calculator. If you simplify properly, you're going to obtain 12 meters. Okay, then we are given now the acceleration of the object. So I want you to note this part. If you are given a consideration like this part that we are given, the formula for displacement. It's either you're going to work this mathematically from your mathematical calculations. We know that if we are given these values for displacement, for you to obtain the acceleration, it's simply the displacement that you're going to have. From the displacement, you find the derivative that you're going to have. So I'm simply saying, guys, if you are given the displacement that you're given in this case, so what you're going is to find the derivative according to the time that we have in this case. So this is going to be 10 minus 4t, all right? So we've got 10 minus 4t. So from our 4t, the value that is affecting our t in this case, which is a negative 4, is representing our acceleration, which is negative 4 meters per square second. All right, so we are given negative 4, then the initial velocity now. All right, for us to have the initial velocity, we are taking from this formula that we have to say our velocity in this case. Okay, let me explain actually maybe properly this part here. We have the derivatives, guys, from our mathematics. They can actually help us. What I'm going to do maybe is to work out this question using another method in another class. Maybe we can understand much better. But if you are given an expression from the derivatives, okay, if you have got derivative from the displacement, you find an expression representing the velocity. So which means if this expression, which is our derivative here, is representing the velocity, which is 10 minus 4t like this, then for us to find the initial velocity, initial means at the starting point. And at the starting point, t is equivalent to 0 seconds. Remember, our t is given in seconds. So initially, t is at 0. So now to find the velocity that is going to correspond initially, that means we are going to substitute into the formula now to say in place of t, we are going to substitute. So our velocity is going to be 10 minus 4 multiplied by 0 like this, which is going to be 10 minus 0, which is 10. And this is velocity measured in meters per second, or you can write as meters per second like this. Okay, it's the one and the same thing. All right, so that is what you're going to have in this case. On 1.34, you need now the time taken to complete 8 meters. Take note what we are given here. The time taken to complete 8 meters. Whenever we are talking about meters, we are representing the displacement previously, the one that we are given, which is measured in meters. So we now need the time when the displacement is 8 meters. So we have to come back to the expression representing the displacement here, where we say the TS is equivalent to 10t minus 2t squared. This is the expression for displacement. So I'm going to write this expression that we are given here. So take note, sorry for this. I'm just going to indicate this one. So remember, we said in this case, so this is 1.3, for our displacement is given by the formula 10t minus 2t squared. So we are now asked to find the time. We do not know this time, but we are given that the displacement at that moment is 8 meters. All right. So if our displacement in this case is 8 meters, what are you going to do? We are just simply substituting in place of s representing the displacement, we are going to substitute 8. So 8 is equivalent to 10t minus 2t squared. I just wish this topic, they just have it also in mathematics so that it can help you much better to understand this. Okay, anyways, we are now back to our mathematical calculations, guys. What are we given? It's now a quadratic equation that we are supposed to solve. So transposing negative 2t squared to the left-hand side is going to be positive 2t squared. We transpose 10t to this side, is going to be negative 10t. Already there is a positive 8 that we are given there is equal to 0. So you're going to solve this equation by factorization, by quadratic formula. I don't know what is best for you. Okay, so if you are to use factorization, let's try to reduce your equation. As you can see, 2 is common throughout. So you can reduce by 2, by 2, by 2 throughout. That is going to be t squared minus 2 into 10, that's negative 5t. 2 into 8, which is positive 4, is equal to 0. So I don't know which formula you're going to use, factorization or quadratic formula, but from our mathematics, if the coefficient of t squared like this is a 1, it's easier for us to apply factorization method. Remember, we just need 2 brackets that we are going to equate to 0 with the t and t. So focusing on the constant term, which is 4. What are the factors of 4? That when you add, you obtain the middle number, which is 5. So you need factors of 4. So the factors of 4, these are the numbers that when you multiply, you get 4, like 4 and 1, negative 4 and negative 1. So which of these when you add, you obtain -5. So definitely that's -4 plus -1. If we add these numbers, we obtain -5. So that means we are going to have -4 in this bracket, -1 is equal to 0. So equating one bracket or each bracket to 0, t is going to be 4, or let me just show you, t minus 4 must be equal to 0, or t minus 1 must be equal to 0 there. So that means if we transpose -4 to the right-hand side, it's going to be positive, all right? Then we transpose -1 to the right-hand side, is going to be +1. So we've got t being 4 seconds or 1 second. But now, what is the proper answer from these two answers that we have? Which one is the proper answer? Okay, let us get back to the first question. I want you to, not to the first, but to the first statement that we had. I want you to see something here. All right, just pardon me, guys. It's because of, okay, I hope we can see. I want us to get back to the first part here. All right, remember we've got two answers that we got, t which is equal to 4 and t which is equal to 1. So these are the values that we have, but we want to see which one is the exact answer here. All right, or t which is equal to 1. This is the displacement taken after 8 meters. That is at 8 meters. Okay. I want you to see something that on 1.31, which happened here. On 1.31, we calculated the displacement in 2 seconds and we got 12 meters. Take note, guys. 2 seconds, it's 12 meters. So it doesn't make sense now to say at 4 seconds, our displacement can be 8 meters. This cannot make sense. Because at 2 seconds, we are already at 12. So which means at 4 seconds, we must be having a greater displacement. So the only displacement that can correspond is when t is equal to 1. This is 1. So actually, it can correspond with 8 meters because it's below 12. So therefore, our t in this case cannot be equal to 4, but it can be equal to 1. So the value of t was a 1. That is the answer that you are supposed to obtain in this case. All right. So that was question 1.34. Now let's get back to question 1.4. All right. So on 1.4, we are given that two bodies with masses of 3 kgs and 5 kgs move towards each other in a straight, take note, in a straight line with the velocities 2 meters and 4 meters per second, respectively. The two bodies remain in contact. That is, they are holding each other. That is in contact. Okay. After colliding, calculate the final velocity and direction in which the bodies will move after the collision. Okay, this is what is happening, guys. We've got two bodies that we have, and they are moving in the same direction. All right, so we want to calculate the resultant that we are going to have, because at the end, from our momentum, remember our momentum is mass times the velocity. So we know that when they collide, the two, the first momentum and the second momentum is going to be the same. But in this case, look what is happening, guys. We have got an object these two objects that we have, okay, this is 1.4. We are told that these two objects, they are moving towards each other like this. This object going to the positive and this one to the negative. So this one is going to the positive. So we are going to have a positive here. And this one, the other one is going to the left, that is to the negative. Okay. So at the end, we are going to be affected in terms of the acceleration that we have. It is going to be the velocity that you're going to have. It is going to carry a negative. Here it is going to carry a positive. But we know that the total momentum that we are supposed to obtain in this case is supposed to be m, which is the mass. Okay, so the mass is the same. All right, so you can write a mass times velocity, that is v1, okay, plus mass times velocity 2 is equivalent to the mass times the final velocity when they are in contact. When they are in contact, so I want you to note something. These are in contact. All right, they are in contact. So let's get back to, because we need to know the final velocity. We need this value here. The mass is not going to change, okay? We need this value, which is the final velocity. So the mass is not going to change. All right, this final mass is going to be the combination of the two. So they collide, so you just combine those two masses. But the velocity now, it's affected because we do not know what is going to happen with this. Okay, so let's get back to the first part. What we are given here. We are given that these two bodies have got 3 kgs. The first one is 3 kgs. The other one is 5 kgs. So what are we having from these masses? So each mass, guys, is affected to its corresponding because they are given as respectively. So the 3 kg is affected by the velocity of 2. The 5 kg is affected by the velocity of 4 because it's respectively. Okay, so it's 3 versus by 2. Okay, but they are moving towards each other. So you're going to take 3 versus 2. All right, so let's combine our velocities here, mass times velocity. So the first one we said is 3 by 2. All right, sorry for that. Let's see if we're gonna win. So this is 3 multiplied by 2 plus mass times velocity for the second one. But now this is moving to the left. So it is going to carry a negative. All right, so let's see what we are given there. We are given 5 versus 4. So it's going to be 5 times negative 4. The velocity is the one that you use as a negative, okay? So that's 5 times negative 4. This is equivalent now to the total mass. So this, let me write as MT, the total mass of the, because they collided, they are now moving in one direction together. So you add the masses, which is 3 plus 5, that is 8 times the final velocity that we do not know. So it's now an equation that you're supposed to use to solve for VF. So 3 times 2, that is 6. 5 times negative 4, that is negative 20, is equivalent to 8 VF. 6 minus 20, guys, that's negative 4, which is 8 VF. So just divide by 8 both sides. So our final velocity is going to be negative 1,75 meters per second, or you can write it as negative 1,75 meters per second like this. It's still one in the same way. The negative there, what does it represent? It represents that our final velocity can be written as VF is equivalent to 1,75 meters per second to the left. You are now writing the direction, the negative, remember, it's going to the left or to the west. All right, so these are the two possible answers that you can write there. All right, so that was question 1.4. 1.41. I don't know why did they write 1.41 because it's just one question, was just supposed to be 1.4. Okay, anyways, that was just a matter of writing. Let's get back to question 1.5. I'm just going to remove this part, okay? So on question 1.5, we are now given that a body moves from rest in a straight line with the uniform acceleration according to the law. So take note, we are given how the body is moving. It's given by the law, V is equivalent to 3 plus 2t. This is the formula for the final velocity in meters per second, where t is the time in seconds. Wherever we see t, that's the time in seconds. So the question is, what is the initial velocity of the body? Initial, we are now back to that question that we did previously, where I referred to you whenever you are given initial, that is the starting point where t is equal to 0. So if t is equal to 0 here, what is the initial velocity? Just substitute. So v is equal to 3 plus 2 times 0, which is 3. 3 plus 0, guys, that's a 3. And this is velocity measured in meters per second. Just like that, guys, you're done. All right, so that was question 1.5. Let's check back question 1.6. So 1.6, we are given that a flat belt moves at 72 kilometers per hour. Okay, so take note, that is the velocity. The tension on the tight side is 500, and the tension ratio. So take note, we are given the tension ratio there, where we know that T1 over T2 represents the tension ratio. That is 5:1 means 5/1. That's 5:1, which is the same as 5/1. All right, so what are we given in this case? We are given that the tension on the tight side is 500, which means we are given T1, which is 500 Newton. And the velocity also which is of 72 kilometers. So we're given a velocity of 72 kilometers per hour. So the question is calculate the power transmitted in kilowatt. So we need the power in kilowatt. Okay, so I want you to note now for this power that we are going to have, our formula was supposed to be power is equivalent to the change or the difference in the tension ratio, that's T1 minus T2 multiplied to the velocity. All right, so these are the forces that we are given in newtons, and that's the velocity which is measured in meters per second. So that you are supposed to convert the kilometer per hour to meter per second, okay? And also to calculate T2, because as you can see, we are just given T1. So we need to calculate T2, okay? So let's do this. Let's find T2 first, then we change the velocity. So from this ratio that we are given that T1 over T2 is equivalent to 5/1. And we have T1 here, which is 500. So 500 over T2 is equivalent to 5/1. So cross multiply here, that's 500 is equal to 1 times 500, 5 times T2, which is 5 T2. So to find T2, divide by 5 both sides. So we have got our T2 here, which is 100. All right, so we've got 100 newtons. We are left here because here we can see that we've got T1, we've got T2. We do not have velocity in meters per second. It's given in kilometers per hour, so you have to convert to meters per second. Okay, how do you convert? From our formula sheet, we are given the formula to convert that meter per second. 1 meter per second is equivalent to 3.6 kilometers per hour. Here we've got 72 kilometers per hour. So how do I convert this to meters per second? It's now you guys from your mathematical calculations. I hope you understand this, that you need 72. So it's going to be on top. So it's 72 over 3.6 multiplied to 1 meter per second on the other side. Okay, so if you divide properly, we are going to obtain 20 times 1, which is 20 meters per second. So we have our velocity in meters per second. So let's just substitute into the formula. Then we've got our power there. So we've got P representing the power, which is equivalent to T1. That is our T1, the one that we had 500. So that was 500 minus T2, our T2, that is 100. Then whatever that we have times the velocity in meters per second, which is 20 meters per second. We've got our power there. So that will be 500 minus 100, which is 400 times 20. And this is going to give us 8,000 watts. So take note, this is power in watts, but the answer is required here. Calculate the power transmitted in kilowatts. So your answer is supposed to be in kilowatts. So how do you convert to kilowatts? Here, kilo means 1,000. So to convert to kilowatts, you divide by 1,000. So if you divide by 1,000 here, your answer will be in kilowatts. That is 8 kilowatts. All right, so that is the power that we are going to obtain as the final result. And so I hope we can see the stages that or the steps that you're supposed to take to attempt this typical question. So that was question number 1 of November 2022 exams. Having 16 marks, as you can see, guys, it was a lot, 16 marks. So for more questions, we are going to be working together for Maison African Motives. Make sure that you subscribe to this channel if you are new, and to share our videos to your friends and colleagues. And also, there is this platform that we now have. Join the membership, okay? If you join membership of Maison African Motives on your YouTube channel, on your YouTube application there, you can see that there is a join there. If you join, it allows you to work other questions separately from the rest, okay? So that enables you to even come up with your own questions that you have. As long as it's for engineering science N3, we work those questions together as a family. And also it helps us to grow as a channel so that we meet other people also. There are so many people that we need to meet. So please join the membership. It allows us to grow as a family again. So anyways, that's what we had, guys, for Maison African Motives. Tune in for more classes that you're going to have revising Engineering Science N3 and other classes for Engineering Nated till we meet again.